So now I just want to point out that parallel to the Trimpot there, we got a Zener diode to maintain about 3.6 volts across the Trimpot. So we're kind of pushing things. The supply is only 4 volts right now, and we can go down to 0 volts and get close to about 3.6 volts, whatever. With only 4 volts, we kind of don't have enough power. So I'm going to go to 5 volts and 6 volts. You're going to see it goes up a little bit, but not a full volt. 7, 8, 9, 10, 11, 12. So it did change a bit, as you can see there. You know, a fair amount, actually. But we just tripled the voltage, and it only went up a little bit. And I'm going back down to 4 right now. So 5, 4. There we go. So, in any case, this is one way to make a steadier Trimpot voltage, even if the supply voltage changes. So now here's our schematic diagram for Zener diode parallel to the Trimpot. What that does is it maintains a voltage relative to the supply voltage. So normally as you change the supply voltage, the Trimpot voltage changes accordingly. But we get a more stable voltage here. It's not perfectly stable. As we saw, the output did change about 0.4, 0.5 volts. But in any case, it held, relatively stable, considering that we went up about 8 volts, 3 times the voltage. So you use the Zener diode reverse bias, and it builds up the voltage across that. This is the actual circuit there. 1000 ohm resistor to get current going through the Zener diode to build up that voltage across it. It's like a release valve. It prevents the voltage across the Trimpot from going up much more than the Zener voltage right there.